In today's lesson, we're going to be learning about what polynomials equations tell us about their graphs. Right? So these are things you can learn about the graph of a polynomial just by looking at its equation. First thing is it tells us its end behavior. So looking at the equation, you can figure out what the end behavior is going to be by using what we call the leading term test. So the leading term test uses the first term in the polynomial, which is going to be the term with the biggest exponent, right? You're always looking for the one with the biggest exponent, right? So you'll have a number, an x, and then an exponent, right? The number in the front we're calling a, and the exponent is, sorry, not a 2. We are calling that n. N for exponent, a for the coefficient in the front of the x. Right? So first, if n is odd, so the exponent's odd, but the term is positive, then your end behavior will look something like this. You'll have on the left, it'll be going down, on the right, it'll be going up. So your end behavior will be as x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity. If you change a to be a negative, so n is still odd, but now a is negative, your graph will do this. So now the left is up and the right is down, so it's backwards. So as x approaches negative infinity, f of x approaches positive infinity. As x approaches infinity, f of x approaches negative infinity. So now we're going to do n is even. So if n is even and a is positive, your n's will do this. They'll both go up. So even positive, they both go up. So as x approaches negative infinity, f of x approaches positive infinity, negative infinity, f of x approaches positive infinity. And for the last one, n is negative and n is even, a is negative, both go down. I did those backwards. Those should say negative infinities. So that's the leading term test. Right? So you can use the leading term to determine what the end behavior will be. Right? Now these middle parts will change based on the graph, but this is going to show you what the ends are going to do. Right? So it might have more than one up and down in the middle depending on the rest of the function, but this will tell you what those ends do. So some other things you can learn. First, you can also learn the number of zeros, right? We aren't going to learn what the zeros are, we just know how many there will be, right? So what polynomial will have at most n zeros. So going back to that ax of n being the exponent, whatever the exponent is the most amount of zeros a polynomial can have. Now, we say at most because it could have less than, just because there are things called repeating zeros, which we're going to come back to another day. So a repeating zero when you solve for the zeros, you'll get it 2 times. That would count as one of these n amounts of zeros. So it has to be at most n, because if the zeros are 4, 2, and 2, really it has 3 zeros, but it really only has 2 zeros, right? One of them is doubled, right? So that's why it has at most n zeros. But it's a small technicality there. Right. We can also learn the number of turning points. So by turning points, we mean this. So this would have it turned here, here, and here. So this little graph I drew would have 3 turning points. Right, so that's what a turning point is. So a polynomial will have at most n minus 1 turning points. Right, and again, that n is the exponent of the leading term. Right, and this is n minus 1. Right, so if the exponent is 3, it will have 2 turning points. Exponent is 4, it'll have 3 turning points. Right? And the last one you can learn is the y-intercept. This one is really easy. The y-intercept is always the constant term. Constant is the one with no variable. So if the polynomial is written properly, it'll be the last term. Right, so 3x squared minus 7. 7 would be the negative 7 would be the y-intercept, because it's the constant. It has no variable on it. Right, so those are all the things you can learn. So we're going to practice one. So here's a polynomial, and these are the 4 things we can learn from it. So first, we're going to do the end behavior. Right, so we look, this is odd, and this, or sorry, that's not, we want to know that this is positive, and n is the exponent, is odd. So positive and odd. If we look at our table here, positive and odd would be our first one. Right? So we know that on the left it goes down, and on the right it goes up. Right? Down and then up. We say as x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, f of x approaches positive infinity. Right. How many zeros? Zeros is n. N is 3, it has 3 zeros. Right. Turning points is n minus 1. 3 minus 1 is 2. There are 2 turning points. And the y-intercept is the constant term, which is negative 2. And that is how you find things from a polynomial. If you have any questions, you can message me on Remind. We can set up a